Push that rock with some math. Let's talk amplitude. So here I have a sine wave. It's been vertically dilated with this 4 out front, or stretched and compressed, whatever language you want to use there. And it's been shifted up or translated up 1 unit. So we know sine has this pattern of 0 to 1, 0, -1, back to 0. But we've been lifted up 1, so all the zeros are now at 1 because we've been lifted up 1 unit. It's been shifted up 1 unit. And this vertical stretch is going to stretch the distance from the x-axis, of course. And in this case, for a sine wave, it stretches the distance from this midline or center line, whatever you want to call this. And notice it stretches it up by how much? 1, 2, 3, 4 units. Oh, that seems coincidental, but no, that's going to be exactly what it is. Because the highest point on sine is 1, and if you multiply the output by 4, the highest output of 1 times 4 is going to be 4. So this highest point, which from the center line, which gives us the amplitude, is going to be determined by this factor of vertical dilation. So the amplitude of this graph is 4, and it's determined by this right here. Not this doesn't affect the amplitude any at all. It does change where it is. Like normally if I had not had this 1 here, well then the highest point would have been, the highest output would have been 4 units. But now the highest output is 5 units. But the amplitude is affected by this. That's the highest output from the center line, and the center line moved from 0 to 1. So let's do another example. Let's do this guy here. So I'm going to draw a sine wave, and I'll draw it with a pencil. And I'm just going to draw a regular old sine wave. So in other words, with my pencil, I'm going to sketch sine x. Well, I know it starts at 0, goes to 1. At pi halves, at 0, at pi, it's back to 0. 3 pi halves, it's at -1. And at 2 pi, it's back to 0. And it's got some curve. It's a wave like so. Okay? But I'm going to change the amplitude to 3. Okay? Now I'll do that in dotted black. So the amplitude should be 3. So instead of 1 unit, it's going to stretch up to 3 units. Instead of -1, it's going to stretch down to -3 units. And so it looks like so. So the pencil graph was sine of x, and the dotted black graph is 3 sine of x. But we want the purple graph. Well, just take this sine wave, whose amplitude is 3, and shift it down 2 units. So this point comes down 2 units. This point comes down 2 units. The 0, 0 comes down 2 units. This point comes down 2 units, and this point comes down 2 units. And there is our sine wave with the amplitude of 3 shifted down 2 units. Math made simple. Simpson math.